Okay, welcome to the video of rational exponents. But let's, before we start, let's look at the two words exponent and rational. As you know, exponents, we can say that exponents, or also we say power, is basically repeated multiplication. And kind of let's go over here and kind of my hierarchy of mathematics, and I've talked about this a little bit in class. But first we started with addition. And to undo addition, I could say this undoes each other. We use subtraction. And now if I go to repeat something, repeated addition is multiplication. To undo multiplication is division. And repeated multiplication is going to be exponents or powers. That's where it goes here. And to undo exponents, we use roots. There we go. So that kind of gives me the hierarchy, and I'll talk about that a little bit later. But basically, exponents, so you can have an exponent to a variable, so x to the third, the power or the exponent is 3, or you can have it to a known quantity, 2 raised to the power of 5. 2 times 2 times 2 times 2 times 2 times 2, 5 times. We can also, later on, you'll see in the next course, is if we do, say, 2 raised to the x power. Now the unknown value is the exponent, but we're not going to talk about that in this video. Rational. Remember in this previous class we talked about what rational is. Rational is numbers that can be written as an integer over an integer. So 3, that's rational because it's an understood 3 over 1. We can also say 1/2. 1/2 is rational. We could say -5. -5 is rational. -5/3 is rational. So we'll talk about any time you have a power that is rational. Now, if we kind of go back through the worksheet, let's talk about the inverse or the undoing of power roots. Well, let's kind of talk about that. That symbol is the radical symbol. Now, the radical symbol has a little thing right here called the index. Now, when we do the square root, the understood index is 2. So if we do the square root, we don't really put a 2 here. It is the second root. Second root and square root are the same thing. What goes under here is called the radicand. Okay, so if we have that, this would be the cube root or the third root of 8. Square root symbol, index of 3, radicand of 8. So if we had, say, something like this, radical 2 times radical 3, since they are both of the same index of 2, we can multiply the radicand. So simply we could say this is square root of 2 times 3, or just radical 6. Now, one of the rules in simplifying a radical is that if the radicand, the number in here, has no factor that is a perfect, in this case, square root, perfect squared term, or if it's a cube root, perfect cube term, if it's a fourth root, perfect fourth term. And we're going to mostly deal initially in cube roots or square roots. So if we looked at, say, something like square root of 24, once again, the understood index is 2. And we could break this up and say, is there any of our perfect squares? Remember, our perfect square other than 1 is 4, 9, 16, 25, 36, etc. So I look at 24, well, that's too big, that's too big. 16 doesn't go into 24 perfectly. 9 doesn't go in there perfectly, but 4 does. So I can split this up into the square root of 4 times 6. And because these are like indexes, I can split them apart and do square root of 4 times square root of 6. Now I use this one because the perfect square in the square root of 4 is 2. So we simplify this as 2 square root of 6. If we did a fraction, I don't know, say something like 9 over, 64, and we did the square root of the whole thing, we can split up because multiplication and division have the same rules. We can split this up. Square root of 9 over square root of 64. Square root of 9 is perfect 3. Square root of 64 is perfect 8. 3 over 8 is as simple as fraction as we can possibly do. Now let's look at one more fraction. If we said we had the square root of 7 over 5. Now one of the things is if we split this up, square root of 7 over 5, one of our rules is thou cannot have a radical in the denominator. Well, one of the things we could do if I extend this radical out is multiply by a foo-foo. 5 times what gets me to one of my perfect squares? Well, shoot, 5. Well, if I multiply the bottom, I have to multiply by the top because I'm really talking about an expression, and I only can multiply by an overall quantity. Right here is 1, the multiplicative identity. So let's go back. So now we can say the top is square root of 7 times 5, or square root of 35. The bottom is square root of 5 times 5, which is 25. Sorry, that's a little bit sloppy. Square root of 35. Oh, nothing of this will go into it, so I'll just put square root of 35. That's as simple as possible. Square root of 25 is 5. And oh my gosh, my radical left the denominator. Okay. Let's see what else is on your thing. So let me go ahead and erase a little bit of this and delete, and go ahead and talk about now weird looking stuff. If I have a negative exponent, say 2 to the negative 5th, well, this is really an understood fraction of 2 to the negative 5th over 1. We have a numerator, or I call it the attic, or the denominator, or the basement. If we have a negative, we can change and take this entire term, the base and what it's being raised to, and move it to the other side. We're left with a 1 on top, and now 2 to a positive 5th power. Or if we multiply 2 times 2 times 2 times 2, I believe we get 32. And that's one way we can do. If we had 3 times 2 to the negative 3rd power, remember, only the base along with the negative goes to the denominator. 3 isn't being raised to the negative 3rd, so we leave the 3 in the top, 2 to the 3rd in the denominator. 2 times 2 times 2 is going to be 8, and that's going to be 3/8. All right, let's do one more, and we'll talk about some fractional stuff. Well, the beautiful thing about fractions, if I say 2 and I multiply it by 9 over 3, when I multiply it by a fraction, so I'm multiplying by a fraction, I'm really doing multiplication and division together. So this could be either really 2 times 9 and then divided by 3. 2 times 9, 18, divided by 3 is 6. Or I can do 2 divided by 3, 2/3 of 9 is, sure enough, 6. So it doesn't matter which way I go. So let me go ahead and do some powers with some fractions. And I can't believe I just undid all of that. So let me do that, grab all this, and then go ahead and see if I can't erase it. I don't know how I do that. But anyway, so one more time. We'll try with all this. And now delete. Who cares? Let's start with a new one. So let's go ahead and say we have, I don't know, 5 raised to the 1/2. Well, on this, the nice thing about it, and I wish I still had my chart over here, but remember on my chart, we had multiplication, division here, then we had powers and roots. Well, the nice thing about raising something to a fractional exponents is we're doing both of these at one time. So we're really taking it to the first power and then to the second or square root. So really this symbol is the same thing as that. 1/2 is the square root of 5. Likewise, if I said 7 raised to the 1/3, that's just the same as the first power and the cubed root. So the third root of 7. So you should be able to convert back and forth between radical form and fractional form, we'll call it. Okay, and then let's do one more. Let's take, oh gosh, 8. And let's go to the 2/3 power. So we have fraction other than 1. So we're actually raising it to something other than 1 and taking a root other than 1. Well, I can either say that this is 8 squared, then cubed root. So 8 squared is 64. And what times itself 3 times gives me 64? Well, sure enough, that's 4. Or I can do 8 cubed root, remember the order doesn't matter, and then I can go ahead and square it. So the cube root of 8, what times itself 3 times gives you 8 is 2. 2 squared is going to give you 4. So that's kind of a quick tutorial on rational functions. Another one I could do real quick, say like 20 to the negative 1/2. Well, I got to have two things. We kind of combine two things together. I can get rid of that negative, and I'll put an equal sign down there, by moving everything, 20 and the 1/2 to the denominator. as a positive denominator. And now really just like up here, this is the same thing as 1 over square root of 20. And I can't have a radical denominator, but guess what? We're all out of time, and we will talk about that in the next couple videos.